Hello everyone, welcome back to another video. In this video, we are going to discuss two small topics from advanced AML, that is multi-layer networks, and back propagation algorithms. So basically, we are going to explore more about these two subtopics from AI and ML, where we'll highlight their core topics, applications, and limitations. So let's get into the topics. Firstly, the multi-layer networks. So introduction to multi-layer network. So it is basically it is also known as a deep neural network, which are powerful tools for modeling complex relationships in data. So unlike some traditional linear models like linear regression, etc., they can be used to understand, learn various intricate patterns and nonlinear dependencies, that is relationships, which helps them enable to which enables them to tackle various problems that were previously intraceable, that is were previously not able to find. Then these network structures are in the form of layers where each layer performs a specific task. There are mainly three different layers: input layer, processing layer, and output layer. So basically the data flows to through layers, and it becomes abstract, allowing uh, high level relationships and concepts between the layers. So next, let us see what is a feed-forward neural network. So it's basically consists of three different layers. The first one is input layer, the hidden layer or processing layer, and the output layer. Input layer receives raw data as information as input. Hidden layer, it performs nonlinear transformations on data, extract features, understand patterns, make the non-dependable relationships, etc. And it output layer produces the network's predictions or the classifications that it has made. Then now another topic that we are going to discuss was propagation. So it basically follows three different steps. The first one is forward pass, error calculations, and then we have the backward pass. So in forward pass, the input data propagates through the network and it generates some predictions. That is, let us consider it has classified two different classes. Then we are going to check what is the error, that is error calculation, that is the difference between the network's prediction and also the original target that is classified earlier or calculated earlier. Then pass, based on error signals, we go in a backward direction in the network to understand how the network has given its solution, or why the network is going in some out of bound ways, or it is biasing a particular class or something like that. Next, we have different optimization techniques in back propagation. So the first one is gradient descent, then stochastic gradient descent, then we have momentum, then adaptive optimization. So gradient descent, it is basically an optimization algorithm where we adjust the weights in the direction of the steepest curve in the direction of the error function. And in stochastic gradient descent, we use smaller batches of data to update weights. Based on these weights, the speeding of training takes place, and it makes sure that it reduces the risks that are being uh, overcome from the previous observations, and getting the optimized backtracking technique. Then we have momentum. It basically it adds inertia to gradient descents, allows traversal of plateaus, and escapes local minima more efficiently. So basically, it acts as inertia, that is something that the force that objects obstructs something, so which helps in traversing the plateaus at a very slower pace, and it escapes the lower minima, that is minimum descent point. Then we have adaptive optimization. There are various optimizations like optimization algorithms like ADAM, then which automatically adjust the running rates based on the data, and it has a very good control over the data traversal where it automatically optimizes based on its data patterns that are found in the data. Then next we have vanishing and exploding gradient problems. Vanishing, basically it decreases exponentially as they propagate back through the network, hindering learning in deep layers. Exploring gradients learn exponentially, causing instability and making training extremely difficult. And so basically, there are two different problems that we can face in backtracking. All backtracking techniques. The first one is vanishing gradients, and then we have exploding gradients. So here in vanishing gradients, the gradients decrease exponentially as they back propagate through the network, which makes reduces the learning in the deeper layers where the network or the neural network learns about the data. It reduces the learning process, that is learning rate in the neural network. And in exploding gradients, it causes instability, which makes sure that once the model is learned, it should train on the data. So during the training process where the data when the model learns from the data, the process becomes unstable, and which makes sure which either moves towards the bias or it sometimes goes out of bound, that is over training or over learning, etc. Next we have various applications of multi-layer networks. So in computer vision, like it can be used in object detection, image classification, facial recognition, and medical imaging. In object detection, like detecting number of head count in the class. And in image classification, basically classifying between two different images, like image with fire and image another without fire. Facial recognitions, like um, with the help of facial landmarks whether a person is drowsy or not. In medical imaging, like understanding whether a person has developed fracture or any cancer thing, etc. Then in NLPs, it is basically used in machine translation, sentiment analysis, text generation, and chatbot developments. These are basically pretty simpler things which we can understand by the names itself. Then we have robotics and controls, autonomous navigation, robot control, and predictive maintenance. The most important thing here in the robotic and control is autonomous navigation and robot control and predictive maintenance, where all the robots should make sure that they learn at very deeper layers, like mimicking the almost all the activities of human brain. So they should think like humans, act like humans, work like humans. So it is very much important here. The multi-layer network neural networks are very much important here. And in financial modeling, it's basically risk assessment, that is risk of investment that you get. And sometimes fraud detection, whether in the market there might be a real object and also copied or thing. You can make sure that whether the investment that you make are real or fraud. And market prediction, that is future prediction. Then next, limitations and challenges. The first one is data hunger. Larger data sets are essential for effective training. Then explainability, biasness and fairness, and computational cost. So first one is data hunger, that is for every neural network a large amount of data is required. Only then you make sure that uh, the trained model is capable of learning and replicating the things that are present in data, either classification or recognition or regression, etc. Explainability, understanding neural network decision making is a challenging process. Then biasness and fairness. Biasness, when you include data of a similar thing, for example, you have only data with fire sets and no data set with no fire, then it is biased, that is it's against it is the data, the model is being trained towards biasness, that is towards the fire thing. Then computational cost. Training deep neural networks requires high computational resources like GPU storage, which are pretty expensive. And required huge investments. So that's it for the video. I hope you learned two basic concepts, that is multi-layer networks and neural networks and backtracking techniques. So the future directions are basically in these, despite they have all these limitations in the field of development and research, they are in the verge of pushing the boundaries where they are trying to advance in areas like interpretability, robustness, and efficiency. So that's it for the video. Thank you.